All right, now we're going to look at number 26. Find the area under the standard normal curve to the right of the given z-score. So this is going to be a little bit more involved than what we've done earlier. Not a lot, but a little bit more involved. So number 26, find the area under the standard normal curve that lies to the right of the given value in question. This time let's work with item number B. All right. And so our given z-score is negative 2.91. Normal curve every time. One problem, one normal curve. Again, we're not using the X scale in this particular item because we're dealing only with the Z. We'll talk about this later, but the Z-score is what we're dealing with for now. Z-score is always centered at 0, and so negative 2.91 is to the left of 0. Notice in this case, we are asked to find the area to the right of the given z-score. I think it's going to help to indicate it this way. We want the area to the right. This is what we're asked to find. So this is given in the problem. We know this is what we're looking for. We need to find the area to the right of the negative 2.91. I use the very technical term, the squiggly line. We need to find the area that corresponds to the squiggly line. All right? So, we look up negative 2.91. Well, as soon as we put negative 2.91 here, we extend this line upward. And the question is now, which way does the arrow go? We're going to draw an arrow from here. The rule is, because this is a left-handed table, the arrow always goes to the left. It doesn't matter what you're given. It doesn't matter what you're asked to find. It doesn't matter whatever else is in the picture. This table is a left-handed table, and so this arrow must always go to the left. When you find the value in the body of this table, it goes on this arrow. It is the area to the left. So let's see what we have. Negative 2.91, that's the table value. We're looking for, the table value we're looking for corresponds to negative 2.91. Make sure you're in the negative region, not positive. Negative 2.9 is near the top of the table in the upper left. Negative 2.9, we want the 0, 1 column. Negative 2.91, the z-score I found, and the z-score you should be able to find, is 0.0018. If you have any difficulty finding 0.0018, you need to look at the video that was earlier posted about using the table values. So negative 2.91, the value we have is 0.0018. The table value is 0.0018. That table value always goes on the arrow, 0.0018. The 0.0018 does not correspond to the answer we're looking for. The 0018 corresponds to this piece. The 0018 corresponds to what's to the left. What we want is the value that lies to the right. So the question is, how are we going to take the given information or the information that we have and use it to generate the information that we need? Do you see the solution? It comes from the fact that the total area under the entire curve, the grand total area, we know the total area is equal to 1. The grand total area under the entire curve is equal to 1. We want this large piece. I'm going to indicate this large piece by shading it with this purple. So we want this purple large piece. This is what we want. We don't have that. That's not what the table gave us. The table gave us this little green bit over here to the left. Well, if we take the grand total 1 and subtract off the piece that we don't want, is it clear? That's going to leave us with the piece that we do want. So, the solution we're going to need is to find the area to the right of negative 2.91. We need 1 minus the little piece we don't want, 0.0018, and that corresponds to 9982, if my arithmetic is correct. And so find the area to the right of negative 2.91. The area to the right of negative 2.91 is 0.9982. And this is going to be the typical thing to do for this table. If what you're looking for is the number to the left, the table value gives it to you directly. If what you're looking for is the area to the right, you end up subtracting from 1 to find the piece that you want. So let's see if we can work another part of number 26. Let's see if we can work number 26 part, let's do part D. Part D, delta. And the z in that scenario is, part D, is 1.09. All right, see if my picture doesn't get too squashed here. Now, how do we know we want the area to the right? Because that's in the directions. All right, so the directions say we want the area to the right. So what do we know? There's the x scale. We're not using it in this particular problem. Z is the only thing we're dealing with. We joined this problem already in progress. We know z is centered at 0, so 1.09 must go to the right. And we want, what is our squiggly line, to use the technical term? The squiggly line goes to the right, which means we want to find that area. This is what we want. Right? We want that little area. Just based upon our picture, we know that should be a relatively small number. Well, the table value associated with 1.09 let me take out my table. 1.0, remember this is positive, 1.0, and in the 9 column, I'm actually entering from the right-hand side of the table. This is very well designed, by the way. 1.09, where they intersect is right near the right-hand column. It is 0.8621, 0.8621, 0.8621. I didn't make my arrow. The arrow always goes to the left, and the table value always goes on the arrow. 8621. So the table value always goes on the arrow always goes to the left. Now, this 0.8621 is this large region. That's the region we don't want. The region we do want is this little bit over here to the right. And similar to what we've done before, it turns out, yes, anytime you want the area to the right of the z-score in question, you take the table value and you subtract it from 1, 0.8621, and that is 0.1379.